Hello students, welcome you once again to GK's maths classes. Today in continuation of inverse trigonometric function, we are going to do problems based on reducing to simplest form, okay, from inverse trigonometric function. Already there are 4 videos that have been put where I have talked about the introduction of inverse trigonometric function, finding the domain and solving various problems including 1-mark questions. Today the problems are a little lengthy and also reducing to simplest form is very important, not just in inverse trigonometric but it will be used in differentiation also. So that is why let me complete this part, very important part. So I have one more video to put on reducing to simplest form. Today we'll do around 6 to 7 questions. More questions we'll do in the next video. So kindly subscribe to my channel and also click the bell icon to get notifications. Thank you for your support. I hope these videos are very useful to you. Let us continue with the problems. Before I go to the problem, I want to show you this particular screen. You can use this screen as a reference to solve the problems. So whenever you come across a problem, when you come across situations like 1 minus x square, 1 plus x square minus 1 with the square root, what to be put I have written here. Okay, it's for your reference. You can always rewind and see. So if you have this with you, you will be able to solve any problem involving reducing to the simplest form in inverse trigonometric function. Okay, so as and when we get a situation, we'll come back to this and see how it is to be done. So maybe you can take a screenshot of this and use it when you're solving problems. Okay, let's go back to question number 1. Now what is question number 1? I want to reduce this to the simplest form. When I say I want to reduce it to the simplest form, if this is tan inverse, I want the term inside also to be in terms of tan. So what I will do here is, this is tan inverse of, this is cos x minus sin x by cos x plus sin x. So when you see this question, you see there's a plus and there's a minus. You know there is a formula which has tan A minus B, which has a minus on the numerator, that is tan A minus tan B divided by 1 plus tan A tan B. This is a simple question. Tan A minus B equal to tan A minus tan B by 1 plus tan A tan B. Now I am going to use that. So I want this to be brought in that form. Now how do I do that? So what do? You know the denominator is 1. So I want to make this denominator as 1. That is the idea. So to make this denominator as 1, I'll divide numerator and denominator by cos x. So when I divide this by cos x, I get 1 minus, what is sin by cos? It is tan divided by 1 plus tan x. I hope you understand this. I'm dividing each and every term on the numerator as well as the denominator by cos x. Okay. Once you have done that, you can see something good happening here. This 1 is nothing but tan pi by 4. This one is tan pi by 4 minus tan x divided by 1 plus, you see that it is actually 1 into tan x. That 1 can be written as tan pi by 4 into tan x, correct? Actually, it's just tan x, but you have to imagine it is 1 into tan x. That 1 should be replaced by tan pi by 4. Now, if you correlate this with that formula, it is actually tan inverse of what? Tan pi by 4 minus x. Correct? Tan pi by 4 minus x. But what is tan inverse of tan pi by 4 minus x? It is nothing but pi by 4 minus x. But you have to check whether it lies in the principal range or not. You know the principal range of tan inverse is minus pi by 2 to pi by 2. That has to be checked. Now how do I check? Using the domain of definition. If you start doing all that, it gets very complicated. So it is a must that you have to check, but generally you don't have to do it in the board exam. For one problem, I'll show you how it is done. Maybe from next question you can try by yourself. If you don't get it, you can always message me. For example, this is minus pi by 4 less than x less than pi by 4, correct? Now I want minus x. So multiply throughout by minus sign. So you get plus pi by 4 is greater than minus x is greater than minus pi by 4. What did I do? I multiplied throughout by minus sign. Multiplied by minus. So when you multiply by negative number, the inequality has to reverse. Now I will add pi by 4 throughout. So I get pi by 4 plus pi by 4 is greater than pi by 4 minus x is greater than pi by 4 minus pi by 4. Now you can see pi by 4 plus pi by 4 is pi by 2 is greater than pi by 4 minus x is greater than 0. If you flip it, you get 0 less than pi by 4 minus x is less than pi by 2, which definitely lie in the principal range. You want it from minus pi by 2 to pi by 2, but I got 0 to pi by 2, which is inside this. So that is why I am able to write tan inverse of tan pi by 4 minus x as pi by 4 minus x. So these domain of definitions are very, very important. If you want to really understand the concept, all this should be taken into account. But in the exam, you don't have to show this step. It is not necessary. This is absolutely not necessary. We will just take it for granted and do. But actual procedure, if you want to really do the problem the right way, all these things must be verified for every question. Until unless you verify, you cannot write tan inverse of tan pi by 4 minus x as pi by 4 minus x. But for the board exam, it is taken for granted that it will work. Okay. So we are not going to check for any other problem. Okay. So let's go on to the next question. Now look at this beautiful problem. This is the very difficult problem, also very lengthy. So let's watch this. Here my domain of definition is this, and here I am not going to break my head on that. Okay. Let's see how it is done. This is tan inverse of, I will write cos x as cos square x by 2 minus sin square x by 2. There are different ways to do this problem. Some people will do cos x as sin 90 minus x and sin x as cos 90 minus x and do, which is shorter, but there's some confusion in that. So I don't want to do that way. I prefer to do the problem this way. This is slightly lengthy, but you don't have to think too much. Okay. Now what is cos 2a formula? Cos 2a formula is cos square a minus sin square a. I like to do the problem this way. If you want, you can even do the problem as cos x as sin 90 minus x and do. That is also very much possible. It is in fact shorter than the method which I am adopting. Divided by, write 1 as cos square x by 2 plus sin square x by 2. Always write it as, cos square a plus sin square a is 1. And sin x, you can write it as 2 sin x by 2 cos x by 2. What formula is this? This is actually sin 2a formula. What is sin 2a? 2 sin a cos a. Your 2a becomes half. So your x will become x by 2. Okay. Now if you watch the numerator, it is a square minus b square, which is cos x by 2 plus sin x by 2. This is too much to write, that's all. Into cos x by 2 minus sin x by 2. Divided by, now a square plus b square minus 2ab. What is that? It is cos x by 2 minus sin x by 2 the whole square. You can even write sin x by 2 minus cos x by 2, but again it will affect your domain of definition. You have to do some adjustment. To avoid that, I write cos x by 2 minus sin x by 2. Okay. As I told you, if you start verifying that, it gets very complicated. So I don't want to make things complicated. So make it like a rule that you write cos first, then sin. Okay, which is not the right way to tell. But by doing this, you don't have to break your head on that. Okay. Now this gets cancelled. Now this is exactly the previous problem. Instead of x by 2 in the previous problem, it was x. So what you do here, divide numerator and denominator by cos x by 2. So what do you get? tan inverse of 1 plus tan x by 2 divided by 1 minus tan x by 2. Done. So now this is tan inverse of, what is 1? Same procedure. It is tan pi by 4 plus tan x by 2. Don't touch this one. Keep it as it is. But you see there's a hidden 1 there. It's actually 1 into. That 1 you write it as tan pi by 4 into tan x by 2. Now you can see clearly tan A plus tan B by 1 minus tan A tan B is nothing but tan of A plus B. Now what is tan inverse of tan pi by 4 plus x by 2? Tan inverse of tan pi by 4 plus x by 2 will be pi by 4 plus x by 2, provided pi by 4 plus x by 2 lie in the principal domain. Okay, that is very easy to verify. If you want, I can do one more sum. Pi by 2 less than x less than pi by 2. Since I want x by 2, divide throughout by x by 2. Pi by 4 is less than 1 by 2 less than pi by 4. Okay, now add pi by 4. If you add pi by 4, this will become 0. Pi by 4 plus x by 2. Pi by 4 plus pi by 4 will be pi by 2. So clearly 0 to pi by 2 lie in the principal range of this. What is the principal range of tan inverse? Minus pi by 2 to plus pi by 2, open interval. This very much lie there. So it is legitimate to write it like this. Is it clear? Again, I am repeating, this process is not at all required for you to verify in the exam. Maybe at home, to have a better understanding of your concept, you can do it, but don't do it in the exam. Now let's go back to the next question. This is again a very, very simple and very nice problem. So what is this? This is cot inverse of root of 1 plus sin x plus root of 1 minus sin x divided by root of 1 plus sin x minus root of 1 minus sin x. So I will change this cot inverse to tan inverse. What is that? Tan inverse of reciprocal. What is that? 1 plus sin x minus root of 1 minus sin x divided by root of 1 plus sin x plus root of 1 minus sin x. So I am using the formula cot inverse of x is tan inverse of 1 by x. This is the formula I used here. Okay. Now I can repeat the same process like what I did in this problem, writing 1 minus sin x as cos square x by 2 plus sin square x by 2 minus 2 sin x by 2 cos x. I can do that. But as I told you, it can also be done differently. Just to show you the variety, I will do this problem in a slightly different way. The easiest way is you write this 1 as cos square x by 2 plus sin square x by 2. Write sin x as 2 sin x by 2 cos x by 2. Do it for everything. Automatically things will get cancelled. You get the answer. But just to make you understand that since I told you it can also be done differently. Now how exactly it can be done differently is what I want you to understand. You can write sin x as cos 90 minus x. Okay. So wherever sin x is there, you replace it by cos 90 minus x. 1 plus cos 90 minus x. 1 minus cos 90 minus x. This is pretty simple, isn't it? Now, I am going to use this wonderful formula that 1 plus cos 2a, which you studied in trigonometry, is 2 cos square a. And 1 minus cos 2a is 2 sin square a. I have given all this formula in that formula page. If you see in the formula page, I have given all the formulas. In fact, whatever formula I have given here will be used there. Okay, so I have given the formula. So let's come back to this. Okay, so I'm going to use that formula here. This is tan inverse of root of, this is 2 cos square x by 2. So I have to divide the entire thing by 2. So it will be pi by 4 minus x by 2. See, you can make mistake. That is why I don't go for this method. You understand? That's why I didn't do the previous problem in this method. But this is shorter than the previous method. But you see, you have to divide the entire thing by 2. If you miss out one, it's a problem. So what will be this? This is 2 sine square half of this. And what about this? 2 cos square pi by 4 minus x by 2. And this is root of 2 sine square pi by 4 minus x by 2. Fairly easily it's done. Now if you see on the numerator, root 2 is common. In the denominator also root 2 is common, which can be cancelled. I am not going to show that step. I think that you can understand. So it is tan inverse of root of cos square will be cos. So it will be cos pi by 4 minus x by 2. And what about this? This will be minus sine pi by 4 minus x by 2 divided by cos pi by 4 minus x by 2. This will be sine pi by 4 minus x by 2. Simple, isn't it? Now this is exactly like the previous question where you got a situation like this. So here you divided by cos x by 2. So what will you divide numerator and denominator by? You will divide numerator and denominator by what? Cos of pi by 4 minus x by 2. So when I do that, what do I get here? I will get 1 minus sine by cos is tan. So it is tan pi by 4 minus x by 2 divided by 1 plus tan of pi by 4 minus x by 2. Okay. So now what do you do? Write this one as usual, the same procedure. You write it as tan pi by 4 minus tan of pi by 4 minus x by 2 divided by, don't touch this one. Can you see there's a 1 hidden here? So that is tan pi by 4 into tan of pi by 4 minus x by 2. What formula is this? Tan A minus tan B by 1 plus tan A tan B. What's the formula? It is nothing but tan of A minus B. What is B? Pi by 4 minus x by 2. Now you can, when you open the bracket, what will happen? You get tan inverse of tan x by 2, which is nothing but x by 2. X lie between pi by 2 and pi. X by 2 will lie between pi by 4 and pi by 2, which is very much in the principal range. So it will definitely work. So this problem can be done like this also. I am giving you another option. You can always write this one as cos square x by 2 plus sine square x by 2, and write sine as 2 sine x by 2 cos x by 2, and then use the formula a square plus b square plus 2ab, a square plus b square minus 2ab. If you simplify, you will reach the answer. But I purposely did this problem slightly differently because you should know how to handle a problem in different ways. So as I've told you, right, this can be done in the way I have done this problem. Okay, so you should know how you can approach the problem in different ways. Okay, if you don't want to do that, you follow the same procedure like the previous problem as I suggested, you will definitely get the same answer. Now let's go to the next question. You have root of 1 plus x square, root of 1 minus x square. Both root of 1 plus x square and root of 1 minus x square is there. Now let's go to the formula page and have a look at it. Now look at it. See this. Look at point number 4. Whenever you come across root of 1 plus x square and you come across root of 1 minus x square, both, it's and, both are there, you put x square as cos theta. You put x square as cos theta. If you put x square as sin theta also, you can do the problem. But I prefer to put x square as cos theta. It will be slightly shorter. Let's see. If I put x square as cos theta, or you can put cos 2 theta, whatever you want. So you get tan inverse of root of 1 plus cos theta. Some people write cos square, it's wrong. You are putting x square as cos theta. And this will be root of 1 minus cos theta divided by root of 1 plus cos theta minus root of 1 minus cos theta. Okay, just I put x square as cos theta. How do I know? Check the formula page, it will help you. Okay, now what is 1 plus cos 2a formula? 1 plus cos 2a is 2 cos square a. And what is 1 minus cos 2a? 1 minus cos 2a is 2 sin square a. So put those formulas here. So what exactly you get? You will get tan inverse of 1 plus cos theta is 2 cos square theta by 2. And what is 1 minus cos theta? 2 sin square theta by 2 divided by, repeat that same formula, 2 cos square theta by 2 and 2 sin square theta by 2. Just like the previous problem, if you see on the numerator as well as the denominator, root 2 is common, that can be cancelled, and the root of cos square will be cos theta by 2, and this will be sin theta by 2 by cos theta by 2 minus sin theta by 2. By now you definitely know what you should do. Divide numerator and denominator by what? Yes, cos theta by 2. So what will I get? I'll get tan inverse of 1 plus tan theta by 2 divided by 1 minus tan theta by 2. 1 plus tan theta by 2 by 1 minus tan theta by 2. Again, you know what to do. What is 1? 1 is tan pi by 4 plus tan theta by 2 divided by 1 minus tan pi by 4 tan theta by 2. Before there was a formula tan inverse x plus tan inverse y. Since it is not in the syllabus, I am not using it. Otherwise it becomes easier. This is tan inverse of what? Tan pi by 4 plus theta by 2. Again, you have to verify the domain of definition. I am not doing it here. So it is pi by 4 plus theta by, I assume that it works, which is pi by 4 plus 1 by 2 into, what is theta? Your cos theta is x square. So theta will be cos inverse of x square. So very, very important. Theta is cos inverse of x square. So this type of questions are very, very important, not just in inverse trigonometry, but in differentiation. They will say in the exam, differentiate this with respect to x. That's all. So if they say differentiate this with respect to x, what will you do? You have to do all these things, you reach this point, and then differentiate. Okay. How to differentiate, we'll come to that later. Okay. Now let's come back to this problem. So you have tan inverse of root of 1 plus x square minus x. Let's go to the formula page. When you have only root of 1 plus x square, what I should do? I should put x as tan theta, or I can put x as cot theta. Okay. So let us see what I can do here. So I will put x as, let us say, tan theta. When I put x as tan theta, what do I get? Tan inverse of root of 1 plus tan square theta minus tan theta, correct? I prefer to put cot, that makes it little easier, okay? I prefer to put cot, it becomes easier. If you put tan also, you will get the answer. You get 1 plus cot square theta minus cot theta. You try for tan, it will definitely work. This is tan inverse of, what is 1 plus cot square? Root of cosecant square. Root of cosecant square is cosecant theta. Correct? So this will be tan inverse of, convert everything to sine and cos, 1 by sine theta minus cos theta by sine theta. So take LCM. What is the LCM? LCM is sine theta. So what do you get on the numerator? 1 minus cos theta. And what is the formula for 1 minus cos theta? I think we have used it many times now. 2 sine square theta by 2. And sine theta, use sine 2a formula. 2 sine theta by 2, cos theta by 2. They get cancelled. What is sine by cos? It is tan theta by 2. What is tan inverse of tan theta by 2? Theta by 2. But what is theta? Theta is cot inverse of x. Cot inverse of x by 2. Don't write cot inverse of x by 2. It is cot inverse of x by 2. Now since I also wrote x is tan, you should understand the difficulty that we face because I put x as tan. Okay, and let me put x as tan. What will happen? You will get tan inverse of, if I put tan here, you get 1 plus tan square, that is secant theta, minus tan theta. Correct? Now what is this actually? This is tan inverse of, convert everything to sine and cos, you get 1 minus sine theta by cos theta. This is exactly like the problem which I did today. You see, instead of having cos by 1 minus sine, I have sine by 1 minus cos. So you can go through this process. I'm not going to repeat it. It will be time waste. So I will get this as tan inverse of, this will be cos theta by 2 minus sine theta by 2 the whole square. You refer to the previous page to check how I got it, in case you don't understand. This is cos square theta by 2 minus sine square theta by 2. Okay. Now you write it as a plus b into a minus b. So you get tan inverse of cos theta by 2 minus sine theta by 2 divided by cos theta by 2 plus sine theta by 2. Now you can divide numerator and denominator by cos theta by 2. So what do I get? Tan inverse of 1 minus tan theta by 2 by 1 plus tan theta by 2. So if I repeat that process of writing this as pi by 4 and all that, so you will get tan inverse of tan pi by 4 minus theta by 2. Okay. So which is nothing but pi by 4 minus theta by 2. From this I'll take 2 outside. What do you get? Pi by 2 minus theta. What is pi by 2 minus, what is theta? Theta is tan inverse of x. Now you know pi by 2 minus tan inverse of x is cot inverse of x by 2. What formula I am using? I am using tan inverse of x plus cot inverse of x is pi by 2. So whether I put it as tan or cot, I get the same answer. But by putting it as cot, it becomes so simple. By making it as tan, it gets a little lengthy. I have skipped many steps. Even then it is lengthy. Now I hope you understand the difference. It makes no difference whether I put tan or cot. It's all about simplification. Okay. Now let's come back to this problem. This is a wonderful question. It's an NCERT question also. 3ax square minus x cube by a cube minus 3x cube. So I always want to make this as 1. Okay. I always want to make that as 1. How do I make that as 1? Divide numerator and denominator by a cube. So if I divide numerator and denominator by a cube, what will I get? Tan inverse of 3a square x by a cube minus x cube by a cube by a cube is 1 minus 3ax square by a cube. Okay. Now this will be tan inverse of 3x by a. Can you see it? A square cancels. Minus x by a the whole cube. Can you see that? By 1 minus 3. A and a cancels. You get x by a the whole square. Now what I do, I can see a pattern here. I will put x by a as tan theta. When I put x by a as tan theta, you come across a very familiar formula in trigonometry. 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. What is 3 tan theta minus tan cube theta by 1 minus 3 tan square theta? It is nothing but tan 3 theta. What is tan inverse of tan 3 theta? 3 theta is 3 into, what is theta? Theta is tan inverse of x by a. Wonderful, isn't it? Tan inverse of x by a. So they may ask you this question to reduce it to the simplest form, or they may say differentiate this with respect to x. Okay? When we come out to differentiation, that time we'll redo it. Maybe that time I won't do the entire thing, I'll just do only the differentiation part. Okay. Now let's come back to this. If it is x by root of a square minus x square, what I should do? Now look at the formula. If it is root of a square minus x square, look at the 7th point. I have to put x as a sin theta, or I put x as a cos theta. If I do that, I'll get it, right? So here what I should do, I will take x as a sin theta. If you put a cos theta also, you'll get little lengthy. A sin theta is better here. Why? Because I will get a sin theta on the numerator, and denominator I will get a square minus a square sin square theta, which is tan inverse of a sin theta. What is common here? A square is common. You get 1 minus sin square. What is 1 minus sin square? A sin theta by root of a square cos square theta. What is square root of a square cos square theta? A sin theta by a cos theta. So they get cancelled. What do you get? Tan inverse of tan theta. What is tan inverse of tan theta? Theta. Now what is theta? You have sin theta is x by a. So you put x as a sin theta. Sin theta is x by a. So what is theta equal to? Sin inverse of x by a. So that is the answer. So it gets reduced to sin inverse of x by a. Okay. I think we have done around 7 questions. There are more questions to do. Well, I thought we will not do it in one stretch. We'll break it into 2 videos so that your concentration span also is better. So we'll see you in the next video with more problems, where we are also going to do some proving questions. Okay. I hope this video is useful to you. Kindly subscribe and also click the bell icon to get notifications of video. Have a wonderful day. See you again in the next video. Bye bye.